created by MindStick's Foundation Tost. Hello, students! Welcome to today's Explainer. Till now, you have learned some of the basics about carbon and hydrogen. Well, today, let us understand the complete roadmap of carbon compounds. We will go step by step, covering the types of hydrocarbons, functional groups, the homologous series, IUPAC naming, and finally, combustion. Let's get started, shall we? Section 1. Types of hydrocarbons, the building blocks. We will begin our journey right at the foundation by exploring the basic shapes and bonds of carbon chains. Take a close look at this table. Observe how carbon compounds can form straight chains like propene, or branched chains like isobutane, or even cyclic chains. And notice those double and triple bonds present in the unsaturated alkenes and alkynes like propene and propyne? You see, the structure literally dictates everything about the compound. Now, it is absolutely crucial to note this one, benzene. You saw it in the cyclic category, but notice how it possesses alternating double bonds in a six-membered ring? This specific arrangement makes it a very special aromatic compound with its own distinct characteristics. So, we have seen pure hydrocarbons. But tell me, students, what happens if we take a carbon chain and we replace a hydrogen atom with a totally different element? Something like oxygen, or maybe nitrogen. Well, that brings us to Section 2, Understanding Functional Groups, the Modifiers. Let us dive right into these special attachments that drastically change how a molecule behaves. Now, what is truly fascinating here is how these heteroatoms work. Look at the OH group for alcohol, or COOH for carboxylic acid, then entirely dictate the specific chemical properties of the whole compound. And it does not even matter how long the carbon chain is. They literally modify the complete identity of the molecule. And this shared identity brings us to a really beautiful pattern in chemistry. It is called a homologous series. Think of it as a series of compounds formed by joining the very same functional group, right in place of a hydrogen atom, on sequentially increasing carbon chains. Section 3, the homologous series, recognizing the patterns. Let us see how this builds into a highly predictable, almost mathematical sequence. If you inspect these tables closely, as we move down the list of alcohols, from methanol to ethanol to propanol, or even down the list of alkenes, just notice how the carbon chain grows systematically, step by step. So here is the crucial takeaway. In any homologous series, each successive member simply adds one CH2, or methylene, unit, meaning the molecular mass increases by exactly 14 units each time. And while physical properties, like the boiling point, show a steady gradation as the molecules get heavier, their chemical properties remain wonderfully consistent. It is like a perfectly ordered family. Now, historically, as millions of these compounds were discovered, using common names like isobutane caused way too much confusion among scientists. No one was on the same page, which is exactly why scientists worldwide got together and developed a universal grammar for chemistry, a logical, globally accepted system that provides unique structural names. Section 4, IUPAC Nomenclature Rules, the Grammar of Chemistry. Let us clearly understand this international union of pure and applied chemistry system for naming these compounds. Please do not get overwhelmed by the large names. Naming any compound is strictly broken down into 3 simple logical steps. Step 1, identify the parent chain. Step 2, add the functional group. And step 3, properly number the carbon chain. That's the whole process. For step 1, as you can see here, we simply count the carbon atoms to find the parent alkane. For example, 3 carbons means propane. Then you just change the ending to -ene or -wine if there are double or triple bonds present in the chain. Simple enough, right? Now, for steps 2 and 3, this brilliantly illustrates how we attach the functional group's name as a prefix or suffix, like adding "all" for alcohol. The golden rule here is ensuring we number the carbon chain starting from the end that gives the smallest possible number to that functional group. This makes the name perfectly unique, like propan-2-ol. No more confusion. All right, so we have successfully learned how to build and correctly name these complex structures using logical rules. But what actually happens when we put them into action? How do they behave in the real world? Section 5, Chemical Properties, Combustion, Compounds in Action. Let us finally look at how they react, focusing specifically on a highly useful reaction, combustion. Look at the equations at the bottom here. You will see that when we look at combustion, hydrocarbons like methane and ethanol burn brightly in the presence of oxygen. They emit heat, light, and form carbon dioxide and water. This highly exothermic reaction is the precise reason we use compounds like propane as fuel in our daily lives. It is an absolute game changer. As we conclude today's explainer, I want you to think about this final question. If modifying just one functional group or adding a single CH2 unit completely changes a compound's behavior, what infinite possibilities lie in even more complex carbon structures? Because understanding these basic, simple rules we covered today unlocks the entire, vast, fascinating universe of organic chemistry. I hope everything is perfectly clear. Keep exploring, students.